explain the concept of an ecological footprint as a model for assessing the demands that human populations make on their environment. We calculate from appropriate data the ecological footprint of a given population, stating the approximations and assumptions involved. And we describe and explain the differences between the ecological footprints of two human populations, one from a less economically developed country and one from a more economically developed country. Agricultural land, open-range cattle farming, the extraction of oil, a river, a coastal fishing village, a closed landfill, and an outfall pipe draining waste into the ocean. Soil contaminated with hazardous waste. The ecological footprint takes into account all of these, for it is the amount of land and water required to supply all of the needs for a given number of people and to assimilate all of the wastes that they produce. The ESS guide defines the ecological footprint as the area of land and water required to support a defined human population at a given standard of living. The measure takes into account the area required to provide the resources needed by the population, and also to assimilate or to collect all of the waste that the population generates. According to footprintnetwork.org, the carrying capacity or the biocapacity of planet Earth is 13.4 billion global hectares. Put simply, there are 13.4 billion hectares of land capable of making a contribution toward the ecological footprint, either by being productive or by being able to assimilate waste from the human population of 7 billion. Given the fact that we have 7 billion people and 13.4 billion global hectares, less than 2 global hectares are available per person on the planet. Given the current level of consumption of the Earth's human population, we would need 1.5 Earths, or to put it another way, we would need 18 months of production to provide the needs of the Earth for 12 months. This current overshoot is forecast to increase by the year 2030 and to continue its increase well into the 21st century. It is important to note that this is just a model, and it is likely that the actual biocapacity of the Earth may be even less than 13.4 billion global hectares. If we were to include waste assimilation for things like heavy metals and plastics, and to factor in water sustainability, which is something that could change from one year to another, dependent upon things like global climate change, then we would realize that there is much more that must go into the calculation of the Earth's carrying capacity and the true ecological footprint of our population. In addition to that, the 13.4 billion global hectares are utilized to different extents depending upon the level of economic prosperity in a given country. For a more economically developed country like the United Kingdom, the average citizen requires 5.1 global hectares. whereas for a less economically developed country like India, the average citizen consumes only zero point 0.9 global hectares. It is useful to examine some of the reasons for these differences. One significant reason has to do with the diet. In many MEDCs, people consume a meat-rich diet, whereas in LEDCs, much less meat is consumed. Consider this area of land. If it were dedicated solely to producing grain and not to raising free-range cattle, then the amount of food that it could produce would be significantly greater. The explanation for this connects to another topic and to the differences between primary productivity and secondary productivity. Another reason for the MEDC-LEDC difference is the consumption of energy. This kitchen is typical of an MEDC like the United Kingdom, and it is powered by a huge consumption of fossil fuels to run the electric stove and the microwave and the dishwasher and all of the other appliances and modern amenities which are widely used in developed countries. Whereas in an LEDC like India, millions are without electricity and running water, and very little energy is consumed in the preparation of meals, and very little meat is consumed in meals. Another reason is the amount of processed food that is consumed in the MEDC, and all of the fossil fuel energy that is consumed in the packaging and in the transport and distribution of these foods. The automobile is another major reason for the MEDC-LEDC divide. In most developed countries, people own cars, and these cars are in most cases powered by the consumption of fossil fuels. In LEDCs, this consumption is a lot less. But in recent years, with development, it has been on the rise. And millions in India are beginning to improve the quality of their life. It is predicted that by the middle of the 21st century, millions more will have improved the quality of their lives. And the typical Indian kitchen will look something like this. This model for the ecological footprint is just that, a simplified description designed to show the structure or workings of a system or a concept. A simple way to allow us to get an idea as to how much of a burden a country places on the planet's resources. A simple footprint calculator, or a model, involves the consideration of two main parameters: the per capita or per person food consumption in kilograms per year divided by the mean food production per hectare of local arable land per year. Basically, a simple equation to allow a country to know whether or not it's able to supply its people with food. Another simple equation matches the per capita carbon dioxide per year with the net carbon dioxide fixation per hectare of local vegetation per year. In both cases, these values can differ depending upon the productivity of the local arable land and depending upon the ability of the vegetation to dissipate carbon dioxide. Let's consider three questions. Why is this model considered as a simplified calculator? What are some ways to lower ecological footprint? And what are some ways to increase biocapacity? This model calculation is simplified because it excludes the land or water required to provide any aquatic and atmospheric resources to take up waste other than carbon dioxide. It does not include the energy and material subsidies imported to the productive land for increasing the yields, like fossil fuels to power tractors or fertilizers that are manufactured in far-off countries. It does not consider the replacement and loss of productive land through urbanization. A simple way to reduce the ecological footprint is to reduce, reuse, and recycle. And a way to increase biocapacity is through the use of biotechnology, such as genetically modified foods, or alternative energy, which would mean less fossil fuel consumption.